Hi, welcome back to the channel. In this video, we are going to discuss about a new problem statement. It's called finding pivot index. This is a Leetcode problem and asked in various product-based companies. Okay, I will give you the link of this problem in the description. You can go and solve it on yourself. You can try it first yourself. Okay, so here we will understand how to solve this problem in the optimized way. So given an array of integers, we have to find a pivot index. So what's the pivot index? So pivot index is the index where sum of all of its left elements is equal to the sum of its right elements. Okay. So in case the pivot index is the first element, suppose the first element of the array is the pivot index itself. So there will be no left element. So we have to consider left sum to be 0. So all right sum has to be all the sum of all the right elements has to be 0. So basically we will also be having negative and positive both elements in the array. And similarly for last element, if the pivot is last element of the array, then our right sum will be 0 because no elements will be on the right. Perfect. Now you can solve the problem in your way. You can think for 15-20 minutes, or you can take your time and solve this. Try to solve this problem in your way, whatever you are going to think. I have given the link in the description. There in the Leetcode you can solve it. Okay, but here we will be discussing about the optimized approach. So let's discuss. So we have taken an example of this array, which is also given in the Leetcode for us illustration. Here the array is 173656. Now here you can see that 1 plus 7 8, 8 plus 3 is 11, and from right 6 plus 5 is 11. So in the middle it is, or here it is 6. On right of it is the sum is 11. On left also the sum is 11. That's why 6, the index of 6 is the pivot index, and that's what we have to return. So how do we do that? So the approach to this problem is we create a two arrays, left sum array and right sum array. So we will, in the left sum array, what we are going to actually do is, the concept is we will consider every element to be a pivot index. Okay, every element, 1 also, 7 also, 3 also, and we will calculate their left sum and store in the left sum array. Similarly, we will consider all the elements to be the pivot index, and we will take their right sum, and we will start from here 6th, and we will say every element is a pivot index, so what will be its right sum, and we will store that sum in the right index or right sum array. Right, then we will match the both arrays, and if any match is found, if any sum is equal, then we will say that we have found a pivot index. Okay, so let's see how do we do that. So first we have to create a left, suppose we create a left sum array, or I just denote it by ls. Okay, for convenience ls, and it is an array. Okay, so how will you calculate the left sum? Now if you see here, I have said that if the pivot is first element, then the left sum is 0. So here 1 is the first element of this array, so for it, for 1 the left sum of the 1 will be 0. So initially it will be 0. So let's start from 7. Now how 7, for 7 we can calculate? So we will take a variable sum equal to 0 initially. Okay, and the logic will be we have to write sum, the previous sum, and we will add the current element. So let's consider our array to be n. So name of our array is n. So n ith minus 1. It makes sense, right? because for 7 we cannot include a pivot index into the sum. So for 7, what will be the its left sum? Only 1 is present in the left sum, and so 1 can be added to the current sum. Current sum is 0. So 0 plus 1 is 1. Right. So for 3, on its left it is 7 and 1. So 7 plus 1 is 8. Right. So 8 is we are taking. For 6 it is 1 plus 7 plus 3. So it is 11. For 5 it is 1 plus 7 plus 3 plus 6. So it is 17. And for 6 again we will get 22. Perfect. Similarly, we have to do for right sum. So in right sum, we will not start from first element, we will start from second element. The reason is, when we are doing right sum, you can see that for last element the right sum is 0 because there are no elements to the right. So this 6 is the last element of this array, and on its right you can see there are no elements, it is the last element. So we will start our counter variable from here. So it will be 0. Okay. For 5, on its right only 6 is there. So 6 will be the right sum of 5. For this 6, 5 and 6 are there. So 5 plus 6 is 11. So 11 is there. For this 3, 6, 5, 6 all is there. So it will be 17. For 7 it will be 20. And for 1 it will be 27. Right. Now we will be comparing the index, first index of left sum to first index of right sum, and so on. Right. Actually this is wrong way I have interpreted. We have to do in reverse fashion. Actually we have to insert in reverse fashion. So I did it just a wrong way. Sorry for this. 0, then, or even you can do it what wait, no problem if you did it right. This, it's not actually wrong. We can just reverse the array. So we have to reverse this right sum because we have started from back of the array. So when we will reverse it, what we get is RS is 27, 20, 17, 11, 6, 0. You may ask that why we then not started from first element. What's the need for this? It's just for your understanding. So that how we are calculating right sum. That's all. See, there are lots of approach to this problem. It's depend on you how you well understood it. So when I was understanding this problem, I understood it like this way, that to calculate the right sum of the elements by taking each one as pivot, I was doing this way and I then reversed it and do it. So I just remembered it. So if you feel convenient in using right sum from beginning of the array, you can pursue and write the logic in that way. Okay, no problem in that, but this way it would be convenient. Okay, so 0 compares to 27, 6 compares to 20, sorry, 0 compares, okay, I remove this one so that no confusion is there. Okay, so ultimately our right array is this one. So 0 compares to 27, no match. 1 compares to 20, no match. 8 compares to 17, no match. 11 is comparing to 11, so we have got a match. Okay, so we have got a match where two sums are equal, right sum and left sum are equal. At what index they are equal? At fourth index they are equal. 0, 1, 2, third index they are equal, so we will return 3. And as you can see that 0, 1, 2, 3 at 6 is the pivot index at third index, right? So for any example you can try this logic. So we will write the code for this. Okay, it's a very simple logic. but a tricky one to derive this. So let's write. So first we take left sum, equal to new int nums dot length, and whenever you are writing the Java program, always remember that write the name of your variables which have a meaningful variable. Don't write ls rs, because that is not good, that doesn't give a good impression to the interviewer. Okay, so this is one interview tip. So we take int sum equal to 0 for initially. Now we will traverse int I equal to 1, as we have see that the here, if you see that we have seen that for 1, okay, the initial its left sum is 0. So we will not start from 1, we will let it remain as it is, because whenever you create a new array, by default all the elements, the value it put is 0 only. So that's the reason. So nums dot length and I plus plus, okay, or you can better put it left sum dot length. Okay, now you have to write some logic. So sum equal to sum plus nums I minus 1, and what you have to do is left sum of ith. So ith left sum will be equal to, so the left sum of ith element. So here for ith I is 1, so at 1 it is 7. So left sum for 7th element, for element 7 it will be sum. We have to assign sum. That's all how we calculate left sum. For right sum we will do it, we will start from second last element in reverse way. So it will be nums dot length minus 2, and okay, nums dot length minus 2, and I will be greater than equal to 0, and I minus minus. Perfect. Okay, and then you can before you write the logic here, just make some variable again reinitialize is to 0, so that we have no errors, and plus nums of I plus 1 here, because we are starting from end of the array, so we need to do plus 1. So plus 1 means if you are starting from 5, so plus 1 means you will be taking, for right sum you will be taking the right element as 6. Okay, and similarly a right sum for I equal to sum. Perfect. Then what we have to do is, for int I equal to 0, I less than nums dot length and I plus plus, you have to just see it, if left sum of I equal to a right sum of I. If this is the case, then return I, or else return minus 1 in case there is no pivot index. Okay, so let's consider the case of this. So we will write one array, we'll pass an array arr equal to 176, what was then 1736, okay, 173656, 173656, and then we will just call the function and let it make it static, so that we can directly call it. Problem number 12 dot pivot index pass ARR. Okay, perfect. Now let's try to run the code. So we are getting 3. Okay, so our index is perfect. And suppose if we uh, remove it, and or maybe remove 5 and write 6 here. Now let's see if we get any pivot index in this case. So we are getting -1 because no pivot index is there. Okay, there is one base case also for negative numbers. So let's check it out. If you are given this negative numbers, 5 times -1 and 0, here -1 and -1 are -2, -1 and 0 are -2. So this is the pivot index again. So the pivot index is 0, 1, 2. 2 is the pivot index here. So let's verify for this negative case. So we are getting perfect. So this is how we calculate our pivot index, and this is the most efficient solution. If you found any other way which is more efficient than that, you can write in the comments section. I will definitely see and reply. So all that's for this video. We'll see you again with some new concepts and problems. Till then, bye bye.